Hello, I'm Szymon Soppa, and I'm a CEO at Curiosum. And today I'd like to give you a presentation about Elixir and why should you consider it for your next project. Before I start going into the details, I'd like to give you an overview what Curiosum is. We are a company that specializes in web and mobile development. We are located in Poznań, Poland. And the reason why I know a lot about Elixir and everyone at our company is because we only use Elixir as a technology on the backend side, as well as React and React Native on frontend. When it comes to frontend, we are more elastic, but on the backend side, it's only Elixir. And we chose it for a reason, and I assume you're gonna learn more about it with the upcoming slides. Yeah, so I'd like to start this presentation with a little overview of what are the stages of a web application. And I would like to give you this overview based on how the business cycle works. Because if I gonna do this, you're gonna realize that there are different programming languages features that we are looking for at different stages. The first one is a very common word in software development companies and startup world. It's called MVP. This is the first stage where you actually want to build like a minimal viable product that can be verified on the market, because eventually what's important for a business when you create a web application is that this business finds its product market fit, so that there is someone who needs the services that this product offers. So we're gonna look for a product market fit with MVP, and we're gonna look for the fastest way that we can create a new iteration of the product, because every product iteration is a new hypothesis. Let's say we assume that this new version of the button will change the way how users buy a product on our page. That's a new hypothesis. That's a new iteration of the product that can bring us better results. So the essence of the MVP iteration is that it should be fast. It doesn't have to be perfect, because if our hypothesis that we base this new iteration on is false, meaning it doesn't really work as we thought, it should not be kept inside of the product. It should be removed. So each iteration can be actually deleted, meaning the modules that we bring to our product can be deleted. So the typical cycle in MVP would be to build something, then measure the results, learn from these results, and again, do the same thing. This is a typical cycle we have in MVP, and we do these cycles as much as possible, as many as possible actually, before we run out of finance. Because of course, startups rely on some kind of financing. It's not infinite. So we have to be careful to do as much as possible to verify whether there is a product market fit on the market. So what kind of features are we looking for on the MVP stage when it comes to programming language we choose for it? First of all, and this is, I would say, the most important thing, is that we are looking for productivity, because as I said, the iterations should be done as fast as possible. We want to iterate as fast as possible. So the productivity is a key here. Second of all, modular design, because as I said, if we design our software in a modular way, and one of these modules are not really used or good enough for the users to pay for it, we can delete the whole module because we don't actually need it. So we validated the module that we added to the app. It doesn't really work as we thought. We can delete it. If we don't build the software this way, we end up with a software that is so much connected. The components of it are so much connected to each other that it's hard to remove something from it because it can break another thing. So the modular design is important here. We also need a framework that supports and speeds up development. That actually is connected to productivity. If we have a framework that can do a lot of stuff for us for free, which has some kind of generators or processes inside of it, libraries that speeds up the development, that's a huge plus because we can do things faster. And of course, it would be nice if this language would be easy to use, meaning the construction of it is easy to use. It's easy to grasp the idea behind it. It's easy to learn it and do something with it. Because again, the key here is to ship the product fast, and ease of use is important on this step. The second step is when we have the product that is already validated, the product market fit is there. We know it, and we know that our product works on the market. And it's the moment when we actually realize it, so that the business might not be profitable yet. We can see that statistics are promising. We can see that it's very possible that our business will become something if we develop the product to the better stage. So the product actually at this stage needs some kind of improvement to become a real thing. So we need to adjust the code in a way that we invest more time to something that works. We make it better. We write the missing tests if there are any. We make sure that our code base will be good enough with the starting point, and we're going to invest more time into this working modules that we written, and these modules found a product market fit in the product. So what kind of programming language features we need at this stage? Again, productivity, nothing changes here. It's still the moment in the business where you actually might not still be profitable. The money might not be there, so the time is still an important factor here. You need a solid tooling, because if you want to have a very stable, solid code base, you need a good tooling to support this process. If you don't want to waste the time on doing this by yourself, you need the tools that can help you maintain a good quality of code as well as be productive. You need the testing support. MVP stage is very hard to do right, because when I said that you need to iterate fast in MVP, it kind of contradicts with the fact that the software should be tested very well. So the MVP stage is kind of finding a balance between how much should I test and how fast should I ship the product, because eventually, if you deliver a product that is fully tested but doesn't work, and you were able to do 4 iterations instead of 16, it can mean that this business will work or not work after all. But this stage is the stage where you really need to have the product very well tested, because this is the starting point for the whole business to grow. And you, of course, need a stability and reliability, because you already have the users that pays for it probably. You validated the product market fit. You want to have a stable and reliable system. So the next step is scaling up. And when it happens, again, your product has product market fit, and your business is most likely profitable at this stage, or can be very soon, meaning sometimes companies are not profitable because they are investing much more money than they make to scale it, to make it bigger. If they would stop a little bit, would reduce the recruitment processes, and would, let's say, earn as much as they do, but do not spend as much as they do on the scaling up, then they will be probably profitable. But let's assume that some of these businesses doesn't do that in favor of speeding up, because the competitors doesn't sleep, right? And the very important factor here is when the user's base or the product usage, that's important, is growing very fast. So either we have a ton of users going into our product very fast, or the product usage is high, very high. Like consider WhatsApp, which had like not that much employees, while having like tens of millions of users using this product. So that's also a scaling process. Okay, and what type of programming language features we need at this stage to make it work? We need, of course, scalability. This is, I think, obvious, but also stability and reliability, because there is no point in scaling our business if it crashes, if it breaks. We need these features. Now, there are a lot of languages we can pick from, and some of them are well suited for some of the stages. Like, for instance, Ruby is very highly productive language, but has a problem with scaling. At the same time, it's less pleasant to do something with C# or PHP than in Ruby. But there might be better choice if you want something to run faster at least than Ruby. So Ruby will be slow when it comes to scaling process, but will be much more productive, which means it's better suited for the first stage. And I'll focus on the Ruby here because in Elixir world, it's actually a technology that a lot of programmers are coming from. Ruby was meant to be the language with Ruby on Rails, which you can use to very fast create a startup and validate its idea. But if you take a look at the products, the very famous products that have been built on it, like Twitter and other softwares, you can see that almost all of them actually dropped the idea of using Ruby when they really hit the scale. So there is obviously a problem at this stage if you choose the wrong language. But still, it's a very good language for the MVP stage. So my question is, considering that we have a lot of languages that are well suited for different stages, do we want to change the tech stack every time our product reaches a new stage? So I think, and that's the reason why I actually chose Elixir a couple of years ago as my main language on the backend side. I think that if we can have one language that you can use both for MVP stage as well as the stability stage and scaling, that would be great. And this is actually Elixir, one programming language to rule them all. That's how I presented it here. But it basically means that all of the stages that I just showed to you are perfect case scenarios for Elixir. You can really do the software fast because of its features that I'm going to present to you. At the same time, it's one of the best solutions, if not the best in the world, that you can use to scale. But let's start with a little bit of a history here. The first release of Elixir was 2012. And the author of Elixir is José Valim. He's from Brazil, living in Poland, by the way. And the reason why I think this is great is that José actually was a core Ruby team member. And he bring a lot of stuff from Ruby world into Elixir that he believed that are productive. But he didn't stop there. He used other languages as the inspiration to build Elixir. And this guy has a lot of experience that he could use to create something really, really great. But let me concentrate on it soon. Elixir is a functional programming language, and it's inspired, as I said, by other languages, by Ruby. However, don't feel like this language is very similar to Ruby. It's not like that, and for sure it doesn't work under the hood the same way. Some of the syntax patterns are similar here, but it's not really that everything from Ruby was used to create Elixir. It's not. It's just a some percentage of the things that you will see in Elixir and Ruby are similar, but a lot of things in Elixir are much more different than Ruby. We also have Clojure and Haskell here. That was also, these languages were also inspiration for Elixir. And the features of the programming languages that I found very interesting in comparison to object-oriented programming is pure functions and immutability, especially immutability, which basically means that we don't have a side effects. This thing in particular is a very, let's say, very unwelcoming from my side feature of what you can have inside of the objective-oriented programming, because in functional programming languages, basically we have one simple rule. We have some input data that goes into functions, and these functions should return a specific value. If the data is the same, the function should always return the same value, because we have one logic, the same data, it should bring the same results. It's true for the functional programming languages. It's not really true for the rest. So it reduces a ton of issues that you could have. And that's why I believe that pure functions and immutability is a great feature of functional programming languages. It just removes a lot of problems. And Elixir is not a language written from scratch. A lot of great features that it has, basically what I want to say is every feature that it has is inherited from Erlang, because it's based on the Erlang. Now, why Jose chose to use Erlang for Elixir? He said that he was kind of disappointed by how he could run parallel functions inside of Ruby and how he could scale it. And before he got into writing the programming language from scratch, which was not really something that he wanted to do, he thought about finding a platform that already works like it should work, and just use it in the project. He found Erlang. It was a perfect case scenario to use it, but what was missing there is this productivity feature, this being able to write software fast and use the modern solutions in programming. So Erlang already had one of the most, if not the most sophisticated platforms for parallelism in the world, but it was lacking this productivity feature. So he used Erlang to build Elixir. So Elixir is built on top of Erlang. It compiles to Beam and runs on Erlang VM. So eventually we have a code that is compiled to Beam file, and there is Erlang virtual machine, that's how it's called, that's interpreting this Beam file and running the program. So as I said, from my perspective, and I could hear this a lot of times, this is the most sophisticated platform for parallel processing. What Erlang had years ago cannot be still found in many modern programming languages when it comes to parallelism. So if you're running a program that is parallel, I would say this is the best choice so far. And what's very important also is that, as I said, Elixir goal was to bring productivity to Erlang, modern solutions that programmers can use to write software very fast. And this year, we could see that it's really working, because every year Stack Overflow publishes results from the survey where they post a bunch of questions about different things. And one of the questions is, which language is the most loved? And Elixir is climbing in this rank, and this year it was ranked as the second most loved programming language. As you can see, 71,000 people responded. So I assume this as a huge success here, because that was actually the reason why Jose started this project. He wanted to bring some productivity into it, into Erlang. And in addition to that, in Elixir world, you have a Phoenix web framework that is used to create web applications. And a lot of generators are there, a lot of things that improves the process of creating a web application. And Phoenix was named as the most loved web framework. And as you can see here, the second one and the third one was not even close. So there is something here that we can obviously see, that this language and this framework for building web applications is really, really loved by the programmers. So the main goal of Elixir is, from my perspective, is working. It's productive. We also have two frameworks I'd like to just give you, say a few words about. We have Nerves, and this is an IoT framework. You can build IoT applications in Nerves written in Elixir. And the second thing is NX with a bunch of libraries that are meant to be used as the machine learning framework. This is a project that was started around a year ago, I think, maybe a little bit more. So you could think that it's not production ready, but it actually is. I can see that it's already used in production in some of the projects. So if you're interested in IoT or machine learning or web especially, Elixir can deliver you with great tools. So to sum up, Elixir is a highly productive language. It's based on the most sophisticated platform for parallel processing, and it's a functional language, which means basically there are no side effects of running the functions. And two of the very impressive things is that Elixir is the second most loved programming language, according to Stack Overflow survey, as well as the Phoenix framework, which you can use to build web applications, is the most loved web framework. Okay, so I just gave you stages of web application, as well as the overview of what Elixir is. Now I would like to go through all of these stages and answer why would we want to use Elixir for each of the stage and for all of these things that we do at these stages. So to just remind you, first thing is the minimal viable product. And I named 4 features that we need to build minimal viable product efficiently with the programming language. So reason why: 1, productivity. Elixir by design is created to boost developer productivity. This is what I said, that Elixir was brought to life because of the fact that Erlang, although it had this sophisticated parallel platform processing, it was lacking this productivity aspect. So Elixir by design was created to be productive. There are a lot of tooling things inside of Elixir that were there from the beginning that allows you to do the work efficiently. So you don't have to worry about the tooling, and you can focus on what matters. There are a lot of libraries. As I said, it's a 10-year-old language, so it's not like super new, but it's still not super old. But there are actually libraries for almost everything, except for some API wrappers for some of the services. But I think that this particular thing is not something that you should worry, because creating an API wrapper is a very fast process. It's more like the API should be written and documented in a good way. But it doesn't also mean that there are no libraries for APIs. I just can say that it's not like every API is covered. And the next thing, and the last thing actually about the productivity, there are frameworks that support development in various ways. We can use Phoenix for web development. We can use NERVs for IoT. We can, for instance, use NX for machine learning. So if you want to build an application and then add some layers to it, add some new modules, you can use actually Elixir for various things. And that's, from my perspective, a feature of productivity when it comes to Elixir. Okay, and modular design. Elixir is built in a way that we focus here on something called context. And this is a foundation for a business logic inside of the application. So the contexts are actually modules where we have different modules within the application, like authentication, like if we are talking about the shop, for instance, we can have the shop module. We can also have a blog module where we write about these products. So there are different modules within the app, and contexts are responsible to define each of these. So we have this modular design here. And actually in Elixir, we have something called modules that groups common logic, meaning the functions. So Elixir, although you can do this differently, but the attitude here is to create the software in a modular way. And the next thing was the good framework that supports and speeds up the development. So as I said, we have the Phoenix at the core of web development here, which has really a lot of great stuff inside of it. That's why it's named the most loved web framework in the world. We have a lot of generators. We have a good documentation. Elixir really has great documentation. It has a tool that supports this process very, very well, and you don't have to worry that there is no documentation in most of the libraries. When it comes to Elixir. And there are various libraries that we use for modern web development. So things like GraphQL, authorization, authentication. We have stuff in place to make it work outside of the box. And there is something called Phoenix Live View, a very interesting topic. I would say that this is the only solution on the market where you can actually render things like you would do in React, but on the server side. So in essence, it means that you can do front-end interactive interfaces only using the HTML as well as Elixir. You don't need JavaScript in this process. And this tool is really growing when it comes to what it can do. It's very nice, and I would say still some things probably will be added to it, but you can already build production ready products with it, and it works really, really well. So Rails have something similar. I'm not sure how it's called, but I know they have it, but it has a problems at some point where you're trying to scale it. It cannot support a lot of users. In Phoenix, it's something that can support easily hundreds of thousands of users on one machine, or even up to millions, which I will cover very soon. And as I said, it's not only web. You can actually do IoT as well as machine learning here. So we have a lot of nice frameworks that you can use from day one to speed up the development. Okay, then ease of use. We have a hiring process at Curiosum where the junior developers have to do some kind of a small project in 3 weeks. When I say small, I mean a couple of resources inside of the app, authentication, some kind of the CRUD operations. And most of the people who are applying for this job first have to learn the Elixir because they haven't had a chance to work with it. And I can tell you that a lot of them builds the product as well as learn it in 3 weeks, which from my perspective means that you can really learn it very fast, as well as use it very fast to build something. That's why I could already see it really tens of times that you can build some kind of MVP prototype in less than a month. It's very nice thing. And from my perspective, that means Elixir is easy to use to some extent. There is a functional design with pipes and pattern matching, which really makes it much easier from my perspective to write self-documenting code. And we have this immutability, as I said, that removes a lot of problems, which means no side effects. So it's easy to use it because there are no side effects, no problems happening as you would have, for instance, in Ruby. And just a moment. Then we go to the next stage, which is development and improvement stage. And we had these four things that matters here when it comes to programming language features. I already told you a little bit about productivity and Elixir, so I'm gonna skip it, but we're gonna go to solid tooling. And solid tooling helps you manage a code in a way that is healthy. So Elixir tooling, yeah, it's very easy to have a healthy code in Elixir if you choose the right tooling. And you can name a couple of things here that I would say that are important to consider when you write Elixir code and make it solid. And it's mix. This is something that was back in the early days of Elixir. It helps you maintain the dependencies inside of the projects and all of the details about it. A formatter, which allows you to format code in one particular way so that you don't argue with the rest of the team what formatting style you would like to apply to the code. And code analysis tool that can, for instance, tell you a little bit about security of your code, about the quality of it, or the documentation coverage. Everything here is in place, as well as hexdocs, for instance, which is used for documentation. This is what I said when I meant that. This is what I meant when I said that Elixir has a good documentation support. So the tooling is here. And then we go to testing support. We have a bunch of libraries that we can use for unit testing, for mocking, for HTTP request response recording, and also end-to-end integration tests. So you don't have to worry that something is missing from this. You have everything you need to write good tests. And stability and reliability. There's no shared state here, so it's much easier to create a software that doesn't break on this point. There is a sophisticated error recovery model. This is something that Elixir has because it uses OTP, and OTP is Open Telecom Platform. Basically, all of the whole mechanism behind the power of Erlang. In Elixir, there is a concept that you can have processes that supervise another processes, and if one of these processes under the higher one will be down, then the higher process can actually decide what to do. Should it be started again? Should it be stopped? What should we do? Because of that, Elixir server won't stop if one of the processes will break, which means that server will still operate, and the thing that stopped working can be recovered. And it doesn't really only apply to web applications, it applies to everything. If you write Elixir application, you can decide what to do when something breaks. In addition to that, there is a lot of improvements also to how the functions work when something when there is a success as well as there is some kind of error. So it's easier to grasp some errors, display it to the user. This platform is just ready to deliver a solid stability and to recover from errors very well. And the most important thing here is that Erlang was actually built to be reliable as well, because the authors of Erlang had to create a system that will work well for telephony. As you know, telephony is something that it should work, basically. If you call to someone, that the connection should not be dropped, it should be restored if something breaks. It should be very reliable. So Erlang was designed to be reliable. And this particular feature, as well as the parallelism, is, I would say, the most important factors of what Erlang is. So we move on to scaling up process. And two things were important here when it comes to programming language features: scalability as well as stability and reliability. So scalability. As I said, Erlang has this OTP, and I would say the error recovery system here, how we supervise process, is again the best platform out there that you can use to do this kind of things. And also Erlang and Elixir, of course, as well, they use lightweight processes to handle huge load on the server. It means that in other programming languages, often you would have this, when you create a new process, you create actually a system process. It consumes a lot of server resources. When it comes to Erlang and Elixir, there is something different. There is a lightweight process defined inside of the Erlang VM machine. And it uses much less resources than the system process would use. In the effect of it, you can actually create much more processes than you would be able if you would use another language. There is a law called Moore's law, which basically says that every 2 years, a number of transistors will double. Every 2 years. Every 2 years, number of transistors will double. And you can see that so far, it actually worked. It's happening. But I would say that we can double it anymore so efficiently as we did, because doubling the amount of transistors means that you have to make it smaller and smaller every year. And we already got to the place where these transistors are so small that it's very hard to design something that will be able to maintain this trend. So very soon, and this is not something that it's my opinion, this is consensus from the whole IT community, we will not be able to double the number of transistors, so that our machines will not become even more efficient in terms of the resources they have. But what is the solution to this problem? The solution is known for years already in the industry, but for some reason it's not something that you would think of every day when you program. But the solution is very simple. The software that we write has to use the resources on the machine very responsibly. So the best case we can have here is that we have a program that uses all of the resources that this server, for instance, have to process a program. We don't need to create another server to take more load on the server. We can have one machine, but instead use all of the cores of this machine to handle bigger load. And in Elixir, processes are auto-scaled on all running cores. So if you run a Erlang virtual machine and interpret the bin file that is created, it will actually use all of the cores that the processor have to create more processes, which means that Elixir use the machine in the best possible way to process something. So I would say that would be the solution here to the problem we have with the Moore's law. We will not be able to double the transistors endlessly. We have to think of the software in a way that it should be more, it should be designed in a way that can do more on the same machine instead of adding new machine when, because we want to take more load. So Elixir is really, really great when it comes to that. And I don't want to be like someone that tells you something here. I want to give you also an examples of what other companies already did to support this this idea I just presented to you. So this is an article from WhatsApp blog, and they said 1 million is sold 2011. It was 2012. And they informed that, as you can see today, we have an update for those keeping score at home. We are now able to easily push our systems to over 2 million TCP connections. And that's a very interesting thing when you think of it, because as I said previously at the beginning of the presentation, WhatsApp was able to maintain a system that was able to take like tens of millions of users, if not the hundreds of users, while having like, I don't know, 50 programmers inside of the team or even less. That basically means that they had a very stable system that was able to take a huge load while having only 50 developers in place. And the only thing is an example from Discord, which also uses Elixir. To be precise, Erlang was used in WhatsApp. In Discord, they use Elixir. They have crossed more than 12 million concurrent users across all servers, with more than 26 million WebSocket events to clients per second. And Elixir is powering all of this. Elixir is just known for being a stable solution in a systems that should be working for millions of users. So on the scale phase, it's really great solution. We have other reasons here. I'm just gonna go quickly through it. Programmer satisfaction. I have to point out that because of the fact that Elixir is 10 years old, and because of the fact that we have already so many programming languages, it means also that we don't have as many programmers in Elixir as we would have in JavaScript, for instance. But what stands out in the community here is that the programmers are much more satisfied than working with other programming languages. As I said, Elixir is the second most loved programming language. And what you will hear repeatedly is that programmers that do actually use Elixir, they have a high satisfaction from using this technology in a daily work. And there are very few of them dropping this technology to something else. From my perspective, this is a very important factor if you work with it, because you obviously can see that programmers are satisfied. The other reason is the exceptional core team. Elixir has really great core team that works on bringing new stuff. Jose in Elixir, Chris McCord in Phoenix. They are having really great ideas of what they can do with this technology, how they can improve it. And I would say the best thing you can do that are happening right now in Elixir world can be seen in the Phoenix live view that I mentioned some time ago. There are a lot of great things happening there. So if you're interested, you can check it out. Friendly and helpful community. That's especially important for the newcomers. As I said, programmers' satisfaction is important. The language itself is created in a way that it's satisfying to use it, but what cannot be what is also a huge factor here is that we have a community of developers that are very friendly and helpful. And you can see Jose, for instance, or Chris McCord, the creators of Elixir and Phoenix, appearing many times in many discussions. When someone have a question, they just pop in and give their ideas, very friendly. So this is what really can be observed in Elixir. These people are very friendly. And big companies use it. It's not like the tech is just for a hobbyist. PepsiCo, Discord, Spotify, Pinterest, all of these uses Elixir on production. So if you're interested, you can see, you can just type PepsiCo Elixir in the internet. You will find some stories about it, how they use it. And what I could see that is that all of them were actually very happy with this technology, not dropping it in favor of something else. It's really helping them maintain a huge load in places where they need it, and they need a stable environment to maintain a big number of users doing something. And it's battle tested since 1986. Why 1986? I said that Elixir was created in 2012, but I also said that Elixir is based on Erlang, and everything in Elixir is also Erlang. So if you want to say if given technology was proved to be worthy, was proved to be stable, and work in a good way, we have to consider here Erlang, and it actually shipped. At some point, most of the telephony systems was based on Erlang. So if you ever use the phone, the chances are it was powered by Erlang software. And the same applies to web, because if you think this through, telephony is not that much different from internet. It's just a net of devices connected to each other. And why not put something that works in telephony into web experience? So that's why I would say Elixir is a very stable and reliable platform for web development, because it was battle tested in telephony with Erlang. And that's it. I would like to say that I would like to just say that, as I said, Elixir is Erlang. If you consider it in your project, think in a way that whenever you use Elixir, you use a stable platform that already proved itself to be worthy. And there is a lot of proactivity happening there. So you can be sure that programmers will be satisfied. The software will be shipped pretty fast. And it's going to be something that has a lot of modern solutions instead of the old ones that doesn't work anymore. I haven't heard that some business owners were actually saying that they chose Elixir back then, but they wouldn't do that anymore. I actually hear from business owners that they would do it again. So you can ask yourself whether using the, let's say, more mature or maybe longer on the market technologies is the factor that we should take into account here, or should we take into account that we should pick a technology that can actually work through all of the stages of this development cycle and will deliver a high satisfaction to both the clients, programmers, and will just work. So I would say this is a summary of Elixir. If you have any questions, you can ask it here on the comment section. I will have like 5 minutes to answer them. You can also visit our website, curiosum.com, if you're interested in building products in Elixir or React. You can keep in touch with us. There's also my profile on LinkedIn if you'd like to keep in touch and ask some questions, or our contact email where you can send an email to us. Thank you very much, and I'll just stay here for a minute or two to check whether you have maybe some questions.